Hi folks, we're going to take a look at page 350, number 20. So they're giving us that two triangles are similar to each other, and they give us the ratio of the corresponding sides, which is 3/5. Okay, and they want us to find the ratio of the perimeters. So let's draw a diagram to represent the situation here. So say I've got some triangle ABC, and let me call the side lengths. Okay, since we're talking about the ratio of sides, it makes sense to be working with these side lengths here. So A, B, and C. And so now the second triangle. Okay, so if we take the ratio as being 3/5, so let's draw a triangle that's smaller. Okay, so let's draw something that's similar but smaller. So this corresponding side to A is going to have a length of 3/5 A, since they gave us the ratio. Okay, that means this side, which is corresponding to little b, is going to be 3/5 B, and this is going to be 3/5 C. Okay, and what they want us to do here is they want us to find the ratio of the perimeters. So let me call this triangle 1, and I'll call this triangle 2. So what I'm going to do is I'm going to find the perimeter of triangle 2 with respect, so the ratio of perimeter 2 to perimeter 1. So this perimeter to that perimeter. Okay, so what is the perimeter of the second one? Well, it's just the sum of these three sides. So it's 3/5 A plus 3/5 B plus 3/5 C. Okay, and then the perimeter of triangle 1 was just going to be, again, the sum of these three sides. So A plus B plus C. Okay, so the question is can we simplify this? Is there some relationship between this numerator and that denominator? Okay, now this is something we haven't looked at yet, but I'd like you to think back to grade 9, and I'm hoping you'll see some relationship between these two expressions. Okay, so let's take another example. I'm hoping you're remembering that this might have something to do with what we call distribution. So if I have some expression x plus y plus z, and I multiply that whole expression by some number, say 2, I can rewrite this expression by distributing that multiplication to each term in the bracket. So this can be rewritten as 2 times x plus 2 times y plus 2 times z. Okay, these two things, these two expressions are completely equivalent. Okay, so you can also go backwards and take this expression and write it as 2 times x plus y plus z. And I'm going to do something similar here. I'm going to rewrite the numerator not as 3/5 A plus 3/5 B plus 3/5 C. I'm going to rewrite it as 3/5 times A plus B plus C. Okay, now just to convince yourself that these things are equivalent, we'll just redistribute it out. And you'll see that you get exactly the original numerator. Okay, but now look what I have in the numerator and denominator. Each has a factor of A plus B plus C. So remember, factor, we're talking multiplication. Here we have A plus B plus C times 3/5. This is, think of it as A plus B plus C times 1. Okay, so we can reduce this fraction because they have a common factor in numerator and denominator. And what are we left with when we reduce this fraction? Just 3/5. All right, so now previously you were asked to determine a relationship between the ratio of the areas of two similar triangles given their the ratio of the corresponding sides. So here it seems as though the ratio of the perimeters is exactly the same as the ratio of their corresponding sides. So this could be something that you might be asked to actually prove for a general triangle and not for a specific example like this here. Okay, but so let's just recap the setup of this problem. So step number 1, always start with a diagram. Okay, step number 2, use the fact that they gave us the ratio of the sides. They didn't tell us what A, B, and C were equal to, but I know that the ratio of the sides is 3/5. So that means the second triangle that I'm working with will just have sides 3/5 A, 3/5 B, 3/5 C, and then The next part is they were asking for the ratio of the perimeters, so find the ratio of the perimeters. Okay, so I wrote them out and I was able to reason out that I could rewrite the numerator in this alternate form, and from there I was able to reduce the fraction to get my answer. Okay, that's it for this one.